The number one risk to our planet is widely unknown, yet it is not some secret conspiracy. It's just a bit more complex than Kim Kardashian's Instagram feed. It can actually be easily understood, however, if you take it in pieces, and there's only one place to begin, with the sun. So what can the sun do? Let's make it simple and start with the last time the sun did something we hope we don't see again for a long time. Well, today we have global connections, power grids, cell phones, the internet, but the world did not look like this just a few decades ago. And if you go all the way back to 1859, you would have found telegraph wires in the most developed and advanced parts of the world, but that's about all there was connecting them. We didn't have a way to monitor the sun the way we do now. We were limited to using filters and reflectors. But even then, we could not see in ultraviolet wavelengths and X-ray like we can today. If we could have done that back in late August of 1859, then we would have known a storm was brewing. Richard Carrington was watching the sun in the limited way he could, and if not for him, we might not know what happened next. A massive solar eruption, now known as the Carrington event, blasted the Earth with so much energy that the telegraph wires caught fire. Operators got shocked, and when they unplugged the machines, the telegraphs kept transmitting. There wasn't anything else to destroy, but what if such a thing happened today? Power grids, satellites, communications and information systems, all at risk from the energetic particles and associated electromagnetic effects of these solar eruptions. Back then, nobody had electricity, so the Carrington event was mostly a minor inconvenience to those wanting to send a message. But imagine if today, the world went dark all at once. In a crisis, store shelves are empty in hours. ATMs, gas stations, refrigeration, banking, water pumps, cell phones, air conditioning, central heating, not going to work. This isn't like resetting a breaker, the grids, transformers, everything's fried. If it takes a decade to regain some semblance of normalcy, just how do you make it through that period? Let's take a look at just what we're dealing with. Step 2. Now that we know what the sun is capable of, what exactly are these solar eruptions? Dense areas of magnetism, called sunspots, contain particle flows and highly active magnetic fields. When the fields cross each other or become disturbed in some other way, these particles can surge to nearly the speed of light, releasing X-ray energy called a solar flare. This can have energizing effects on our technology, but the ozone and atmosphere do a good job protecting the surface of the Earth. The particles that can be ejected are another story. Those can be planets worth of material, all highly energetic and moving at hundreds of miles per second, not miles per hour, hundreds of miles per second. Those are coronal mass ejections, CMEs, and CMEs are what we're talking about here. CMEs tend to be as big as their corresponding solar flares, and from lowest to highest, solar flares get rated A, B, C, M, and X. These are on a logarithmic scale of energy, and we really don't have to take too much notice until we hit M class. Keep this in mind for the logarithmic scaling. An X1 solar flare is 10 times bigger than an M1, and so on up the scale every 10 levels. This is important for part 3, understanding that Earth is tremendously vulnerable to the sun right now. The Carrington event was at least an X20, and most solar physicists say much bigger. We weren't quite seeing that a decade ago in the early 2000s, but X10s occurred even into the middle of the decade. A few satellite glitches took place. One grid blew in Sweden. That was near Halloween of 2003. In 2011, the sun got active again, but only up into low X range for the most part. X6.9 was the largest flare we had. That continued through 2013 with only one real technological event of note. The SkyTerra station had problems during an X3 event in March of 2012, but not much happened here on Earth. Makes sense, 5 to 10 times weaker solar activity than the previous decade. Then the sun began quieting down and everyone, including myself, mistakenly thought the Earth could take a little snooze on this aspect of natural disasters called space weather. But in June of 2015, the less active sun was still putting out CMEs, and even though the flares were 10 times weaker than a few years earlier, 100 times weaker than a decade before, the geomagnetic storm that hit Earth late in the month was at the second highest level on the charts, and among transformer fires and power issues, they had to shut down the airspace over New Zealand due to radar failures caused by the geomagnetic storm. Then, the solar flaring sort of shut down for a while, but a usually minor space weather maker known as filaments continued to erupt. These can produce large CMEs, but they have to be large themselves. These were small, just like the CMEs they produced. Nevertheless, despite being puny space weather, the U.S. East Coast had systems malfunction during the impact and storm events, and hundreds of flights were delayed. Telecom, internet, more power disruptions occurred. 1 month later, we had a different kind of space weather still. Dark corona holes seen here putting out super fast solar wind, which can act just like a CME. One of those events caused a major blackout in Ireland, while another caused electrical fires and transformer failure reports to surge by a factor of 10 during the storm event, and caused the peak power plant in San Diego, SDPG&E, to shut down their systems due to voltage concerns. That's the system built for the middle of the summer energy usage spikes. Then came November, and the month began with even more coronal holes. The speedy streams from those hit Earth like a baseball bat, driving strong magnetic storms across the globe and forcing Sweden to ground air travel for the third such event in 5 months. The radar guys said they just saw static. Literally everything you can expect to go wrong if the electricity isn't right seems to go wrong during these solar events. We're talking about tiny solar flares here, small filaments erupting, and corona holes that are not supposed to rival the power of big solar flares and CMEs, all producing the type of effects we would worry about with a big one. It's just that these are on a smaller scale in terms of what the sun is doing. This was not happening just a few years ago, the technological problems, and certainly not in the years before that. So what does that mean? What would it take for the sun to cause a global blackout now? Well, in the year 2000, someone might have said X30 or higher, direct hit with the CME. If you had asked me back in 2012, I'd have said about the same thing, maybe X20. But given what we saw happen with M-class flares, small filaments, and coronal holes, could you imagine if it was just 10 times worse? What if 100 times worse? An X5 solar flare in CME is something the Earth should handle without much more than some pretty auroras in the sky, but that is 50 to 100 times stronger than what took us to the edge of global effects multiple times in the second half of 2015. Can we handle an X10? Can we handle an X1? Is this trend of vulnerability going to continue? Will we see C-class flares dropping power grids? The better question is, why is the Earth so much more vulnerable to the sun now than even just a few years ago? Well, among the few who are looking into this question, there are two prevailing ideas. First, remember the sun has been weakening in its activity in general, causing calmer conditions throughout the solar system. Perhaps even a smaller CME presents a big change in those conditions, meaning that small solar events can act big at Earth. That's the first idea, but the second involves Earth's magnetic situation. Earth's magnetic poles are actually shifting, and as that happens, Earth's magnetic field is weakening. This is important because it is our shield against the sun and supernovas and other scary things from space. Let's take a look at a video lesson on this exact subject called 5 Truths About Earth's Magnetic Reversal, the weakening of Earth's protective shield against these solar events. Let's see about step 4, Earth's weakening magnetic field and the magnetic reversal. While Earth's magnetic pole shift doesn't exactly make the mainstream news headlines, it's not exactly a state secret either. For more than a decade now, scientists have been publishing evidence that Earth's magnetic poles are in the process of reversing. In 2003, the public got a huge leap in learning as NASA published their foundation article on how Earth was changing in this way. They plotted every position of the North Magnetic Pole over the last 175 years, and we can see that the 1831 to 1904 pole migration during the first 73 years was fairly normal, but that it was followed by a much larger jump over just 68 years, and then jumped that same distance in only 29 years. The pole had been moving slowly for hundreds of years, seen in purple, pink, and red. But then the 1900s come along, and we go orange into yellow and green. The North Pole has certainly begun to shift. And while the south magnetic pole is moving more slowly, it is definitively shifting too and has now left the continent of Antarctica, coming up in the southeastern Indian Ocean. Now the North Pole's position was not easily discernible on the Mercator map, so we'll switch to the Arctic view, zooming in so we can see that the North is breezing by the actual geographic pole as it speeds up towards Siberia. Please notice that the distance jumps get smaller there at the end. Also notice that those are predictions rather than actual readings. And the past 3 updates to these databases have all predicted that slowdown incorrectly. So let's not allow that apparent slowdown to fool us this time. The poles are shifting faster and faster. Part of Earth's magnetic system is the magnetosphere, Earth's magnetic shield. As if the shifting poles were not enough, we notice a progressive weakening of our shield similar to the pole shift. It's weakening faster and faster and faster. As of the year 2000 update, our field had lost 10% of the strength it enjoyed before the magnetic poles began to shift. And since then, we have noted further weakening, large breaches in Earth's magnetosphere, and then more weakening. In fact, as of late 2010 or early 2011, Earth's magnetism was down 15%. That is not exactly a great trend you want to see, and it continued with the 2015 data as well. As these poles continue advancing, the SWARM mission has taught us that the trend of magnetic field weakening is continuing as well. So where are we now here in 2015? 17%? 20%? More? While we're talking about the strength of the magnetic field, please note that it is not homogeneous across the planet. There are 3 areas where stronger protection is afforded to our planet by the fields above. One of those is centered in northern Canada, peaking out around 60,000 nanotesla. A slightly stronger field can be found above Siberia, and the strongest field, nearing 70,000 nanotesla, is atop the southern magnetic pole. However, there is a weak spot as well. The South Atlantic anomaly, where the field protection drops to less than 20,000 nanotesla, and where the Van Allen radiation belts dip into the upper atmosphere during solar storms, and where the cosmic ray reading record was taken, is quite the thing. SWARM is already detecting single event upsets around the world, with the majority coming in areas where the magnetic field is weakest. Far fewer overtop the area where the strongest fields can be found. So not only are the magnetic poles shifting faster and faster, but Earth's magnetic field is fading faster and faster. You would think a magnetic reversal would occur with one pole going in one direction and the other pole moving around the opposite side of Earth, keeping the poles pretty much on opposite sides of the planet, but that is not what we have here. The North Pole is heading across the Arctic towards Siberia, while the South comes up from below Australia. Because the North Pole is moving faster, their meeting place appears to be below the equator near the Indonesia Bend. This is also important because in February 2014 we posted the video called Disturbance Under the Ocean. The South Bali buoy, which was removed from public record the day after that video was made, was showing a dramatic seafloor rise of thousands of feet, indicating something was happening below our feet, and it happens to be where both poles are moving. Even more interestingly is the opposite side of the planet. The Earth can't have north and south poles in the same place, so if one shall remain at the South Bali buoy, the other one should pop out somewhere around here. I say somewhere because the magnetic poles are almost never exactly on opposite sides of the world, so it would be this general area over to the left, just between the Bermuda Triangle and the South Atlantic anomaly. Best guess for which one of those would get the pole is up to you, but the fact remains, our poles are shifting towards one another. Let's quickly pause here to dig deeper. Those new pole positions are actually not randomly situated on Earth. The pole place near the Caribbean sits between the weak South Atlantic magnetic field anomaly and the Bermuda Triangle, a magnetic anomaly east off the southern United States. The place where the poles are meeting is between those strong Australian fields and the Dragon's Triangle, a magnetic anomaly similar to the Bermuda Triangle. At some point, you'll want to stop ignoring coincidences like that, but back to the show. Unfortunately, the end result of magnetic reversals is not such a happy tale for our planet. Our magnetic field protects us from the sun, which would strip our planet's atmosphere without the protection. Way et al. Brilliantly correlated each of the previous great extinction events on Earth with these magnetic reversals. Because of the extra oxygen loss into near-Earth space, Earth is also at risk from major star water events, like Noah's flood might have been. The star water danger here is detailed in a video called Superflood. You can also research arc storm to learn more about the smaller version of the superflood. There is a new danger now, however, that was never present before. Way above our heads, we find electric layers, magnetic fields wrapping around our planet. We've been talking about them in this video. If we lose our shield, we are at risk for a danger that can happen much more quickly than an oxygen loss. The greatest danger that solar eruptions pose to Earth is electrical. The sun can surge so much energy into the Earth that transformers and grids could be destroyed. We could be without electricity for years. Now, while many scientists admitted that a reversal was potentially underway, others have yet to reach that conclusion, and those who had always thought it would take hundreds or thousands of years to complete. But a few Berkeley scientists just blew that wide open. In case you couldn't tell from the pole movement speed and the speed of the field weakening, at these rates of change, we don't have hundreds or thousands of years left. The official word is that reversal can happen as quickly as 80 years, a human lifetime. We're already 100 years into this one. Look, there's no sense in being afraid of any of these things. That won't help anyone. But you should ask yourself, are you willing to bet on the Earth stopping in its tracks and reversing this cycle? Or is this shift and the speed with which it is hastening something you wish to care about? Millions of years of patterns, decades of observable data with the increased solar effects as our shield weakens. Well, what will be happening to your body as the sun has its go at our planet and our electrical way of life? Again, many people don't know about it, but the data is out there. Strokes, heart attacks, blood pressure, migraines, seizures, and more can all be affected by these solar storms. So what happens when our protection continues to fade away on a global scale? Now, if you have half a logical brain in your head, you're probably asking yourself why you haven't been hearing about this on the news. Well, technically you did, or you could have, assuming you've read everything that comes out in the science realm every day. Nobody's making a big fuss about this because it requires you to know about a lot of different topics, and even if you do, this topic has the ability to cause panic and fear. So what do we expect? The government and the news agencies to do anything remotely close to starting a riot? Of course not. The highlights to take away here are that Earth's magnetic field is now weakening 5% per decade rather than 5% per century, and it's probably speeding up still. The evidence can already be seen in the space weather effects on the airline industry and can even be seen in the weather. If the math and observations hold true, and millions of years of magnetic reversal patterns on Earth continue, the consequences could be dire. So let's say you want to know more. What do you do now? We made magnetic reversal with one goal: to put all official data on this topic in one place, give you the resources to investigate for yourself, and attempt to clearly communicate the most important points. Some of the facts you heard about here are in that list just below the videos, which are just pretty to look at. Each one of those fast facts can be clicked on to learn more from the original source of the information, and below we have all the media coverage and publications on the topic, just proving this is not a secret. All of those, of course, are clickable as well, so you can go dig your own rabbit hole. But that will only give you the foundation. A good place to keep up with what's happening now is spaceweathernews.com, built to be the one-stop shop for monitoring the sun and its effects on Earth. The news feed tracks significant news, and the daily reports on space weather, the Earth and Sun, come out at 6:30 a.m. Eastern Time, 365 days a year. To know what we're reporting and to understand all the charts and graphs on that page, you'll first need to click What is Space Weather, where you can become a space weather expert in just 1 hour. It's video learning designed for ages 17 and above. You can get free alerts via our Twitter feed, always the first place we update a major event, and you can go back and find previous daily videos at that link here. The daily news videos also appear at the top of suspicious0bservers.org. I recommend everyone watch the free daily news. It's only a few minutes. And also, take in the wealth of free material that can be found on this website homepage. Now, there is more if you want to dig deeper, and it's about 200 DVDs worth of material for the price of a Big Mac. But you don't need to spend a single cent to understand that from June to November of 2015, we got years worth of solar storm effects on Earth, which might normally just mean the sun was extra active, but in fact, it was 10 times weaker than it was just 3 years ago and 50 to 100 times weaker than it was a decade ago, yet the Earth still trembled. Our protection from those solar storms, our magnetic field, is fading, and that is not at all a coincidence.